Today we will see the method to find the resistivity and resistance of the frustrum, that is truncated cone. This question was asked by one of the subscriber in the comment box. So this is the answer for that. If you have any such a question only in electromagnetic theory and quantum mechanics, you can give your comment or your question in the comment box. I will try to answer the question as early as possible. Now, you take this is the truncated cone shape. We have truncated. Now, the resistance of this cone is resistance of the material is equal to rho resistivity, which is constant for a material, multiplied by L, that is length divided by area. This is the definition for the resistance. Now you take our case. This side, that is the where radius is small. If you take a small volume element, which is very much close to zeros, small volume element, it contains some resistance. That resistance, let us take, that is R1. That resistance is R1. So remember that we are taking a small volume element which is very small, close to zero. Similarly, we are taking another volume element here, uh, for which the resistance is R2. So there is a slope here. This is the slope. Uh, Then this is a straight line equation. Let us say this green color, I have shown a line in green color, that is length is L. So uh, this is a straight line. It follows the straight line equation. Y is equal to mx plus c. Here c is naturally the R1 resistance at this end, and m is the slope. Slope is uh, generally, what is slope? Slope is dy by dx. Here uh, dy, change in y, is equal to R2 minus R1, and tx, the total length L. So m is equal to R2 minus R1 over L, and x. This C we are taken that because we are starting from resistance R1, that is at the boundary. It's a constant. So we are taken that as R1. Now, what is TR? This that is resistance, small resistance, is equal to this L is equal to X. I am taking a small volume element uh, of thickness Tx. This is Tx, and this is Y. This radius of sorry, 1 minute. This radius of this at a particular point is equal to y. I am taking this as y. This radius as y. So y is the radius. So then what is the area? Rho we have taken as it is. L we have taken small volume element, that is Tx. A is part is area volume under consideration is the area which I have shown in the yellow color is pi y squared. So radius is y, so pi y squared. That is pi r squared from that equation. But here y is equal to mx plus r1 because we have taken c as r1. So I am replacing y square by mx plus r1 whole square. So that is equal to y square. Now you integrate to both left hand side and right hand side. You take the constant. Here you have constant rho over pi is a constant. Then dx over mx plus r1 whole square. This can be rewritten as Here integration is from 0, this point to L. So 0 to L. Right hand side also 0 to L. But if you integrate 0 to L, this TR will become R, total resistance. So rho over pi, integral between 0 to L. This mx plus R1 square I am taking to the numerator, that is mx plus r1 power minus 2 tx. Now we have seen that r is equal to rho over pi, integral between 0 to L mx plus r1 minus power minus 2 tx. Now you take the terms inside the bracket, that is mx plus r1 as u. So I have taken u as mx plus r1. Now you take the derivative. Tu is equal to, if you take derivative of r1 constant, it will be 0. Then this will become m dx. Uh, dx is equal to du over m. So now I am replacing. This will become u power minus 2, and tx will become du over m. So I am taking that m. Also, we have to change the limit. Here we are changed the variable by u. So what will happen when mx plus r1 is equal to 0? If x is equal to 0, here x is equal to 0, you will get the lower limit as r1. And upper limit, x is equal to L, then this will become L plus r1. Because u is mx plus r1, x will become L, upper limit. So L plus r1, u power minus 2. Now, if you integrate it, you will get 1 over u minus, of course, minus 1 over u, you will get. So, limit is between R1 and ML plus R1. Now, first you apply the upper limit. So, this will become 1 over ML plus R1 minus the lower limit, 1 over R1. Now, what I am going to do is, I am replacing this M by this one. M is a slope which is equal to, we have seen, R2 minus R1 over L. So now this L and this L will get cancelled. This L and this L will get cancelled. So you will get R2 minus R1 plus R1. Minus R1 plus R1 will become 0. So this will become simply 1 over R2. Here you have minus 1 over R1. So here also we have a negative sign. You keep it in your mind. Now we got R is equal to minus rho over M pi 1 over R2 minus 1 over R1. I want to bring this negative sign inside the brackets. Then this will become 1 over R1 minus 1 over R2. If you take R1 and R2 as common in the denominator, then R1, R2, you will get R2 minus R1. So I am rewriting this as R2 minus R1 divided by R1, R2. Uh, Now here there is a M. So this M I am replacing. M is the slope. Replacing by R2 minus R1 over L. So you bring this L to the numerator, because this will go to numerator. Then you will get L into rho divided by R2 minus R1. Here also there is R2 minus R1. So this and this will get cancelled. So finally you will get R is equal to rho L here, rho L divided by pi R1 and R2. How to check whether this result is valid or not? You take R1 is equal to R2, which is equal to R. This will become a cylinder. When R1 is equal to R2, this cone shape will become cylindrical one. So this will become r squared. So pi r squared is nothing but your A. So R is equal to rho L over A. So this is rho L you have, and in the denominator you will get pi r squared, which is nothing but area. So what we got as a result is a valid one. Thank you very much for your support and watching my videos regularly. Thank you very much.